Hi, my name is Sarah Hartman, and I am a student at the Gatton Academy of Mathematics and Science in Kentucky. And my research is about atrazine concentrations in drinking water supplies in 3 Kentucky counties. I'm working with Miss Jacqueline Basham and Dr. Richie Taylor of the Department of Public Health at Western Kentucky University. What is atrazine? Atrazine is the second most used herbicide in the United States. It's used to prevent pre- and post-emergence of broadleaf weeds, and it's mostly used on corn, although it is used on other crops such as sugarcane and pine. Atrazine is unique because it is a chemical in the triazine class. You can see in this molecular structure that there are 3 nitrogens that are all double bonded together. This is classic of a triazine. Atrazine is very mobile and resists metabolism, which is very evident in its occurrence in ground and surface water during growing season and its prevalence in the Midwest because of the amount of corn that's planted there. Triazines are known endocrine disruptors and carcinogens, which makes atrazine a little more toxic. Atrazine is shown to have multiple adverse effects on amphibians and mammals in the environment. Tyrone Hayes is a well-known researcher. He conducted trials with atrazine's prevalence in frogs' habitats. He treated the environments with a relatively low level of atrazine, and all the treatments were less than 3 parts per billion. 3 parts per billion is the maximum containment level given by the EPA. What they found was a very large decrease in testosterone, and that it demasculinized the frogs. Another study on atrazine looked at its effect on female rats, where it was shown to cause a delay in pubertal and sexual development, as well as an increase in fetal resorption rates. The overall goal of this research project was that we wanted to see the difference in raw and finished atrazine levels. We used the EPA's atrazine monitoring program to pull the data for the counties and analyze the occurrence of atrazine in the water supplies. Before we get to the graphs and results, I'd like to point out some other considerations to take in. Karst topography is extremely prevalent in Kentucky, as Kentucky is the #1 source of karst in the world. Karst is defined as the type of terrain formed by the dissolution of soluble rocks such as limestone, dolomite, and gypsum. This type of topography allows for precipitation to penetrate the soil and flow into the subsurface of the ground from a higher elevation, generally towards a stream in lower elevation, which dissolves small fractures in the bedrock. This leads to large cave systems as well as sinkholes. Due to the direct flow of conduits from surface to groundwater and back, contamination can quickly reach a drinking water supply. Let's look at this figure. So this is a map of Kentucky, and you can see that in the dark blue, that is defined as the area of a high potential for karst. So I'm from right here, which is Bowling Green. Bowling Green is the home of Mammoth Cave, which is one of the largest caves in the world, and lots of sinkholes. A couple of years ago, there was a sinkhole that collapsed in the National Corvette Museum, and it trapped lots of cars down there. That was right there, and that is because there is a very high potential for karst in that area. There's also a little concentration of it here in Lexington around Versailles. Let's get to the graphs. So before we start actually talking about the trends that are prevalent in these graphs, I want to kind of take you around what this graph is actually showing. In the blue, you see raw water levels. Raw water is source water that comes from a stream or a lake. It's very direct. Finished water is after it has been through a purifying system. It's basically drinking water at that point. So finished water has been filtered and cleaned. I've marked here the MCL is at 3 parts per billion. That's given by the EPA, MCL, maximum containment level. At 0.3 parts per billion, adverse effects were seen in zebrafish, and at 0.1 parts per billion, adverse effects were seen in amphibians, and this is from the study that I mentioned earlier with the frog habitats. All right, so this graph is from Ohio County Public Drinking Water System in 2016, and there's a couple of trends. You see the atrazine levels really spike towards late May and early June, and that is because that is the start of the growing season for farmers. There is also another little spike down here towards November, which indicates a use of it on winter wheat, but that is not confirmed by any means. It's just interesting that there is another spike. This graph shows around the same thing, only it's from Butler County's public drinking water system in 2016. There's, again, another spike towards May, June. There's another one in late June, and a little bit of a spike here in November. This graph outlines Muhlenberg County's public drinking water system. It has another spike here with another spike here. The important part of these graphs is the amount of finished water that is higher than the raw water levels. So in the first graph, there was a really, really, really high level of finished water. I'll just go back here that you can see, and that is higher than the raw water levels. So around 23% of samples in this one had higher levels of finished water versus raw water. Around 17.3% had higher levels of finished water versus raw water here. You can see that around here, here, here. And here, 14.8% had higher levels. So why is this important? The karst tendencies of this region highlight the possible human health impact. If anything, there should be a cause for concern because of atrazine's effects on amphibians. Like, we don't know what other effects could be at play because of the amount of pollution that's going into the environment. A little bit more information about our data. The EPA's monitoring program is an annual collection of atrazine levels. This occurs seasonally every year, and what this data more broadly shows is that consumers are being exposed each year. As I said before, there could be a possible human health impact, but we don't have direct proof. But the fact remains that there is still a very high exposure. A risk assessment and will need to be conducted, and more research will need to focus on that and observed health outcomes that are related to Kentucky citizens consuming atrazine-contaminated drinking water. Thank you for listening to my presentation. Have a great day.